In this video, we are going to go a bit deeper into ES modules, where we are going to see that how ES modules can be used in browsers also. So modern browsers have inbuilt support for ES modules, which means that ES modules can be directly used inside a browser using script tag. So uh, the only thing which we have to do, that inside script tag we have to write something called type module, something like this. So earlier we saw this syntax where simple script tag is there and src whatever js file is there that you have to write it here, right? Now apart from that, you can write type module. If you write like this, then automatically this file is supported to be a module type also. So let's see that in action. So here we are having a script src index.js. Let's say type module is not there, and let's say we have printed a, okay, and then if we run, then a is printed. Fair enough. Okay, now how can we see that this thing is module and it is running? So the simplest way to create a module is that, like, I do something like export const x is equal to 5, which means that now it should be a valid module, then only this syntax will work, otherwise it will not work, right? Let's try to run this, and you will see that unexpected token export, which means that this export syntax is not understood, which means that this file is not being recognized as module, which means that somehow we have not told browser to use this file as module, and that is where the type is equal to module comes in picture. So if you write type module and now you refresh, now you see that it is working fine. So you can understand that natively these things are working fine. Okay, so that sort of syntax is will be fine. As we will see here, that what is its purpose, you might directly import modules directly from some URL. Okay, so you can directly write at the top, import something from directly some URL, and those ES6 like syntax can directly be used here if you use something like type module. Okay, let's take a step back and understand it from the beginning. So let's remove this for now, and let's have a simple console log A. So you understand that when this thing was type module and when this thing was uh, export const this thing, then obviously this thing is working. But even if you remove this, right, then also this thing is being treated as a module because you have written type module here, right? So this thing will still keep on working. That thing export thing was written just to show you that when it was not module and then you're writing export, then it will throw error. So but that is not the case now. So right now let's take a simple example where you are just printing a from this file, and right now just remove this thing also, and let's print a few more things from JavaScript, and let's simply use the script tag only rather than having a separate file or something. So let's say I'm writing x or something, and then you can write something like b, something like c. So you can see like multiple script tags are there, and x, and here inside index.x index.js a is printed, and then here b is printed, here c is printed. Okay, now let's refresh this and see that, yeah, x a b c in that order it is printed, because that is what is expected, right? The everything is synchronous, and one after another it is run, and if this script is encountered, then there is no async or defer keyword, which means that it will be downloaded, which means that it will be just fetched this new file and it will be executed, then only the next file will run. And that's why the ordering is as it is, x a b c. Now we earlier saw that, yeah, if we write something like defer, then this thing will be this index.js will be executed at the end, which means that x, b, c, and then at the end this script will be executed which has a. So it should be x, b, c, a, and that's what it is, x, b, c, a. So yeah, that is fine. Now just wanted to show you that let's try to write type module here. So right now you can see that just save it, refresh it, it's back to xabc. Now let's write type is equal to module here. Nothing, just now I'm treating this index.js as a module, nothing else. If you refresh, then you see one important thing. Rather than xabc, if you refresh, you are going to get xbca. And why is that? Because just we will mention this in a bit, that if some script is being treated as module, then automatically it is treated like deferred. So you can assume that you have written defer keyword, you can assume it like that. Okay, even, which means that you don't need to write defer. Even if you don't write defer, automatically it is understood that it is defer, because whenever you write type module, then automatically every script tag which is of type module is automatically deferred. Okay, and that's why you get this behavior, that if it is type module, then it is x, b, c, and then a, which is the behavior similar to when specifically defer was used. But right now, since type module is there and it is automatically deferred, that's why defer keyword is not needed. Not only that, even if you apply something like type is equal to module for inline scripts, which is like not a new file here, then also the same behavior will be there, that this thing will be also deferred, and all the deferred scripts are again run in the same order, and that's why the ordering of these two will be same, and it will be at the end after this and this, which means that x will be there, then c will be there, and then a and b will be there. And that's why when you refresh, you see that x is there, c is there, and then a and b is there, because a and b are deferred, and that's why they're at the end, and their relative ordering will still be a and followed by b, because the deferred scripts execute in the same order in which they are there inside the script, inside the HTML document actually. Okay, so that is fine. So this we discussed that you can write script type module here also. You can write script type module, and then for inline scripts also you can use internal scripts, not inline scripts to be precise, for inside HTML file, whatever internal scripts is there, rather than external scripts. For this is external, this is internal. For that also you can use type module in that script tag. Okay, so let's see, this we already discussed, that a script tag loaded with type module automatically behaves like a defer script load. Okay, so defer is understood. Second thing is that it is loaded in a strict mode. Now it is loaded in a strict mode. This is not new, because we already know that all modules, all ES6 modules are executed in strict mode, right? So it should not come to a surprise that if I say that if I write some script, so let's say is strict, and we saw that way to finding strict mode, right? So it is an IIFE with a function which returns not this, right? This we saw multiple times, that this can say that this is strict or not. And obviously this is index.js, which is used as type module, and that's why if you refresh, and you'll see that this is true, this is true, this is, which means that this is strict mode, which means that this is ES module, this is treated as ES module. In order to prove that, just remove this thing, type module, just remove from this here, which means that now index.js is loaded like a normal script. So this is a normal script. In normal script, strict mode is not enabled, right, until unless you use strict at the top. So this should not be strict, right? And that's why is strict should be false. And at the same time it has gone to the top to the here after x, we not at the bottom, because now it is also not deferred, only b is deferred, x a c, and then at the end b is there, because b is the only thing, this part is the only thing which is deferred, because this part is the only thing which is having type module. And again, whatever you are doing here, the same thing you can try doing everywhere else. So let's say you're writing is strict, so let's write it like that, is strict 1, is strict 1, and then use this is strict 1 as a variable, and you can use that at multiple places. So let's say here also is strict 2, and then you can just, I'm using a different variable so that to avoid the conflict of the variables. You can use some other ways also, like scoping block for curly braces, you can use to block scope it, that is fine. For us it should be sufficient. Yeah, so what is the expected behavior? Now you see everywhere inside here also I have printed like whether it is strict or not strict, and here also x b c, everywhere I'm trying to find that whether what is running in strict mode, what is not running in strict mode, right? Now if you refresh, it is very much clear that you can say that x a c, everything is running in non-strict mode, means that they are not treated as modules, and b is true, b is true because it is type module. Okay, and here also again if you write type module, then you can clearly see that a will also become, so right now a is false, but now you refresh, a is also becoming true, and it is deferred also, right? Just to note that strict mode and um, this thing type module, both are completely different thing. It's just that if something is type module, then automatically that is strict mode. So you can see that a is false, not in a strict mode, but even if it is a normal script, I would have written here use strict, right? And then you can see that even if it is not deferred, not module, nothing, but then also it is a is true, because I have used use strict specifically, right? The example which we were discussing, that was simply because of a side effect, that we know that something is module, then automatically it runs in strict mode. So the easiest way to check if there is any confusion, to see that the by default whether strict mode is enabled or not. Otherwise both are completely different things. Okay, so that should be fine. There is no need to use defer attribute, we saw already, because module scripts are there automatically deferred. Okay, now modules are only executed once, even if they have been referenced in multiple other modules. This is important. So what I wanted to show, that let's say there is some demo.js is there, and now a variable a is exported from here, right? Now you can see that from here demo.a, that a is exported, imported, both in the same line. Okay, that is fine. Again in and another variable b is exported. Now if you see here, then what happens, that a is imported and immediately exported, that is fine, but apart from that c is another variable. Now so from a I can reference these two things, from index.js I can reference these two things, right? Let's see so let's say import star as what, let's say foo1 from dot slash foo1, fine, and let's say do the same thing for foo2. Okay, and now let's print it. So foo1 and foo2, let's print it. You'll see that you cannot use import outside a module. So this thing index.js is right now not having type module. That is the first thing. More importantly, we are done doing those sort of experiments, so let's remove everything else. Here we're just interested in this index.js, and from index.js I'm trying to run something, right? Okay, so you can see that something like this is printed, so that is fine. But for this browser execution is not needed. We can directly run like this also, node public public index dot js. Okay, so you can see and again this time here a type module is needed. Why earlier it was not needed? Because earlier it was not executed using Node.js, right? It was directly using browser, so that time it is not needed. But right now, this module system is being executed uh, from the Node.js ecosystem. That's why this thing is needed. Now, so this is expected, right? This is expected. If foo1 has a b, which is 5 and 10, a is already 5 in here. We know that, and foo2 is like 5 and 15, right? 5 and 15. So that is fine. Now, now this is the place where I wanted to highlight this piece of information, that modules are only executed once, which means that you saw here that okay, I imported demo.js from foo2 also, I imported demo.js from foo1 also. So is this the case that this is imported twice, which means that this file ran twice? Is it the case? Let's prove that by just printing log, let's say hello. Okay, and when we run this, we see that hello is printed just once. Okay, which means that even if you import it multiple times, this thing is executed only once, and all the variables which you export, they are like just exported once. Okay, this behavior is called singleton behavior of es modules. Okay, so what it means is that you don't need to bother about multiple instantiation or multiple running of these things. If you're confident, and we are made confident because of this feature of es modules, but now we know that since this executes one, so we can very well do something like this, that new some heavyweight things we can do, something like this we can do. And this is like a proper constructor thing, which means that new object will be created, and creation of a new object takes some memory allocation will be done. And if this is run 10 times, then 10 times this memory would have been allocated, right? And when the things are allocated at different places, so for example, in here in foo1 also a is there, in foo2 also a is there, so then you might be doubting that, okay, is this foo1 dot a and this foo2 dot a are these same or different? Same or different? Turns out both are same, both are exactly the same, and that you can prove here also. You can see that foo1 dot a is equal to foo2 dot a, right? And this is true, and that is exactly because maybe that you are importing it multiple times, demo here also, importing multiple times, but we can clearly see that only one time hello is printed, which means that this whole thing is executed only once, which means that export const a, that export of a is done only once. And that's why I'm saying that a is singleton. Singleton is just a pattern. We'll not go into design patterns, that might be a separate course altogether, but I'm just saying that you can understand singleton like that a variable can have at most one instantiation of that. Okay, which means that if this thing is created, it is created just once. It's not that every time like it is created multiple times. So in that sense, you can clearly see that this is an advantage, and you have to just remember that even if you do complicated things like this and instantiate new construct new objects using constructor functions, or for that matter classes, which we'll learn later, all these things can be done. And similar thing, like you can do export default, and you can very well confidently do new, and some object is there, and you can call you can call that. So the point is that this confidently you can do that if you understand that doesn't matter, doesn't matter how many times you import this function, this thing will be executed only once. And that's why knowing this sort of behavior of es modules is very much needed. Okay, while you're writing complicated code where multiple things are imported at multiple places. And finally, this is quite obvious, but module features are imported into the scope of a single script. They are not available in the global scope. In fact, that is the whole point of using modules, right? If modules are, so if I export A, then wherever A is used, imported. So here again imported and exported again. Now here it is imported like this, right? But I could have very well used something like this also. But the point is that if something like this also, so I can write something like this. The point is that wherever I am importing, that place only, that variable is accessible. It's not accessible globally, right? If I try to access this somewhere else, then it will not be accessible. So you know that here also it will not be accessible because we learned this earlier, that if you do export this export syntax, then while we are re-exporting, the aggregate export is there, then that variable is not bound to any bound to the scope of the file. So that's why it is happening. But and that this is also an example that this thing is not globally defined by anything in module, but that is the whole point of using modules, right? Okay, so now let's see one more thing. So let's see, this index.js with type module is imported, and it has console log a simply, and we do npm start. Then obviously this thing will be printed. A is printed, that is fine. But since this type module is there, then we can have full-fledged imports inside it. So for example, I can have import, let's say, some from foo, some variable a is named export a is happening, right? So I can do something like import a from dot slash foo. Okay, so the idea is that now this thing is pretty much available, and you can see that even if a10 is printed, right, and 10 is the value which is imported, even if only index is imported in HTML, nowhere foo.js is there. But actually, since I have imported it and this exists in the website, which means that relative to index.js, means wherever index.js is there, like inside public, which means at the root, this index.js is there. But wherever this is there, at the same place dot slash foo.js is there, right? So dot slash which, so here foo.js is also there. And since these files are there, that's why even the one file which is just now we are saying that only one file is module, but internally if it imports something else, then that file is available there, then that also works perfectly fine. Okay, so you don't need to import all the modules which you are using directly. So internally this sort of import thing will work out of the box, because now it is proper ES module, right? Type module is there, and this is a ES module, and now there is a proper native support inside the browser itself of ES module, right? Inside the browser itself, proper ES module support is there. Okay, so that should be fine. Next, all these things which we are saying, so dot slash is working, right? Now if let's say some src folder, or some, let's say, scripts folder is there, and inside that scripts folder, let's say foo is there, then you could write dot slash script slash, right? These things you can write relative paths, right? And in fact, let's say this index.js is not here, it is somewhere deep inside, and before that there is a one folder before that, where script folder is there. And then you can write something like dot slash folder, so whatever is there, dot slash dot, something like this will not work. However, why? Because this is the rule. The rule is that either it should start with a dot slash, or it should start with dot slash, or it should start with slash. If these three things are not there, then they are not relative. then they are absolute, which means that now it will look for some in node modules, it will look for something like scripts or something, or let's say even like this you are writing, then also it will look in node module something like, is there some package called foo.js or something, right? Understand? So either it should be dot slash, or it should be dot dot slash, or something like this is also working. Now what is the point, what is the meaning of this slash? Slash means simply like root, right? So now this is not relative, it is like yeah, so relative to the website, you can understand. So anywhere a module is there, and there if you say slash foo.js, which means that is there a file slash foo.js? Turns out there is, and that's why this module, this module can be directly imported, and that's why you can see that this a10 is still working fine. Even if this slash is there, then also this a10 is working. Okay, that is one thing. Second thing is that uh, speaking of slash and this thing, turns out that you can use full-fledged URLs also. So instead of this you can actually write something like this also, full-fledged URLs also. Okay, so you can see that uh, this thing is also working, right? This thing is also perfectly working, because there is a in ES6 there is a proper support for import from directly URLs also, provided that this URL has a script, and it's there are some conditions that its type should be JavaScript, and if it is cross domain. So right now it is not cross domain, right? But if it is cross domain, so let's say in example.com or somewhere else it is there, then then some header should be there for avoiding the CORS policy. We earlier saw CORS policy, CORS, cross origin resource sharing, right? So those things, if origin mismatch is there, so those things should be there. Otherwise it will be perfectly like from locally, like you are importing foo.js, or from remotely some URL, both will work perfectly fine. So this or this, both will all will work perfectly fine. But absolute imports using URLs are also supported. So something like this is also supported, which we just discussed right now, that this is also working perfectly fine. So let's take an example of URL which is not having the same. So here localhost 3000, localhost 3000 is there, right? Let's take another URL, something like this. So this is hosted on a different URL, and if you see, then it has export const foo, which means a function foo is there, which prints hello, and export default an arrow function. So it by default export defaults a function which prints hello world. So foo is a named, so let's use foo and named thing directly from here. So I'm saying that rather than this, we are having a remotely hosted and here we are not using this, rather a function named variable foo, and some default function is there. Let's call it simply func or something, right? So this func will be default import, and this foo will be a named import, right? And from this URL which we just mentioned, from that we are going to call we are going to call foo also, and we are going to call func also. Okay, and the first one should print hello, and the second one should print hello world. And as you can see that it is working fine, which means that this thing is execute when this page is refreshed, then essentially this URL is hit, and this is fetched, and then this is executed. You can clearly see in network also. If you go in network, then you can see that this foo.js and its URL, you can see that this is a remote URL which is accessed, and it is fetched. Okay, however, since this is a remote URL, then you should have something like this all appropriately set for avoiding the CORS policy violation, which means that if modules are fetched from some different origin which is not same, so you can see clearly that here my local origin is localhost 3000 https, right? And this is like https but a different, completely different origin. What is the origin actually? Origin is this thing. You can see that this is the URL, port is 443 and protocol is HTTPS. Okay, now but why there is no course policy even if this is HTTP actually? So local host, these errors will be given for other domains, but for local host, the most of the web browsers, because of development testing, because most of the developers will run on localhost, so these localhost browsers are localhost domains are actually treated as secure context, which means that HTTPS is also, it is assumed that it is HTTPS, which means that if it is HTTPS and it is not HTTPS, then they will not throw errors. So the browsers will not throw error because they know that this is a development server, right? Now, but apart from that, this these other things like port and domain, they should match. They should match. Now you can see that that is not matching, but the error is not coming. Everything is fine because of this thing. Access control allow origin star. So this, if this header in the response is coming, this is telling our browser that it's fine. It's fine. The resource is saying that I'm allowed to be used by any origin, right? And this is what it says. Okay, so that's why this is there, so it is working fine. And more importantly, if you are worried about, let's say, some other URL is there, then actually you can see that if you are using HTTP, then also this is being accessed. You can see that for HTTP also this URL is there, and for HTTPS also this URL is there. Both works, right? Now you might say that yeah, why both are there? So it turns out that let's say this is like localhost, so it is not a big deal. But sometimes if your website, this protocol is not matching, then it will give you CORS error for just protocol also. For avoiding that, we earlier saw this syntax also, right? That in URLs, you if you remove the protocol, if you simply start your URL with // then the automatically the protocol is included as such that whatever is the current, whatever is the current protocol. What is the current protocol? The current protocol is HTTP or HTTPS, whatever, that will be automatically inbuilt. So here we saw that HTTPS thing is automatically HTTPS thing is called because we specifically said that it is HTTPS, right? Right, but here you see that here HTTP thing is called, not HTTPS thing is called, right? Why? Because we did not specify protocol. Then it will take the protocol of the page. What is the current protocol page? Current page protocol is HTTP localhost 3000, not HTTPS, and that's why automatically HTTP is taken as the protocol for this. Okay, so so you can understand that this might help us in avoiding course errors at some places. Though it is very much expected that this thing is needed from the server. Otherwise, definitely course errors cannot be avoided. Okay. So yeah, now you understood that directly remote URLs can also be used, and we also said that yeah, starting with slash, starting with dot slash, starting with dot slash, everything is fine. At most, starting with some URL or something, that is also fine. HTTP colon slash or slash. Apart from that, if you simply use something like this, foo dot, then this will not work. As we discussed earlier, this will not work. Then it will think like this is some package, and it will try to look inside node modules that something package is there, right? For local files, only those formats are supported. Either use full URL or dot slash or dot slash. Okay. So now let's add Webpack into the mix. So we earlier saw that Webpack can be used to bundle various files in our application, right? Now in our case we were seeing that we can directly use modules in the browser only, right? So is the webpack still needed, right? Webpack had the support for ES modules, but now browsers itself have had the support. Turns out still Webpack is very much necessary, because as you can understand that first of all we don't know that whether whether all the syntax is supported by our browser at right now or not. So Webpack can be a good transformation tool. On the top of it, the main thing is that we can if we try to split our application, then we might have of modules, hundreds of JavaScript modules, right? But having more modules will is not good, because there will be too many files and then too many fetches. Okay, so having Webpack is still a good idea, where it will be able to bundle those packages into one, or we can configure it to at most few bundle files rather than having a huge number of files, right? So earlier, for example, we saw that directly inside index.html we had a type module, and directly we had index.js, right? And then we from that index.js we could directly import foo.js, and foo.js was also directly available in public folder, and then that could be directly accessed, because that is also a module, and index.js is also a module. This whole thing is imported as a module. But right now we are interested in normal webpack stuff. So can we use, while development, all the modern syntax like this, all the import syntax and all, but somehow bundle it into a normal file, let's say index.js in public, and that can be normally embedded in JavaScript, and still everything should work as if I have not used any advanced syntax or modules or something like that. So that Webpack can automatically take care of it. That if you're using CommonJS or ES6 modules, whatever you are using, you don't have to do any change in configuration. You can automatically the Webpack will take care of everything. We will simply get index.js and we will embed that in HTML as simple as that, right? Let's so in order to do that, we have moved that to src. We have moved our files and modules, so index.js and one module to src. Now you can have similar 10 more modules, right? But for example, we are just taking one module. So that, let's see how the bundling happens via Webpack, because Webpack also supports this syntax, right? This and all the ES6 modules syntax will be supported by Webpack also. Now firstly, let's try to build this. So obviously, so right now you can see that if we simply try to run using node, then that will be fine, right? src index .js. So you can see that, yeah, a is printed, a is 10. Why a is 10? Because inside foo.js a is 10. So yeah, it works fine. But right now we are trying to use Webpack to build it. So the Webpack will emit index.js file here. So let's see that. So let's see npm run build. Okay, so the first error which we are getting, because now Webpack does not need type module or something. You understand? So now this thing will fail. This thing will fail because this needed type module. But if we are simply using npm run build, then this does not need this type module, because Webpack will take care of it automatically, right? All the corresponding parsing, transformation on all those things will be done automatically, and wherever there are some things, some additional syntax or syntactic sugar, or wrapping of code, additional, all those transformations will be automatically done by browser. You don't have to do it will just go through the walk through the code and do everything on its own. It does not require you to have something like this, right? Okay, so that is fine. Now if we do npm run build, then you see that here a file index.js is generated. That is fine. Now you can see that, yeah, a big file is generated, and a single file is generated. That is more important. You can see that it is saying that foo.js is also here, and it is saying that normal index.js is obviously here, because that is the bundle. So why not we commit this thing for now, and let's take this is just a string, let's say, and let's try to bundle now. Now you see that this thing is pretty straightforward, right? So we bundled this thing, uh, a as a string just and arrow, so that thing is bundled, you can clearly see here. Now if we take into consideration another file, right, foo.js, and we import it, right, and now this is a, let's make use of that variable, and that's why like this. Now you see that still only one file is created, right, which means that basically, and even if like you have tens of modules, everything will be bundled into one bundle, and that is the advantage of webpack, right? Apart from that, let me show you that it is doing something more also. So one by one we'll see. So what are the other advantages? Firstly, everything is bundled into single file. That is advantage, right? Because now I can simply I can simply, so let's say what is this doing? This is printing a, right? Now I took this index.js and I embedded it here, and I simply do npm start, right, and I refresh, and you see that 10, whatever the console on console when node.js, using node.js, when we ran the same thing, we are able to run directly from here without adding something like type module or something, because webpack will by default try to use common js, and even if you use es module syntax, then automatically it will try to create a syntax where both are supported, but internally all the module.exports or something, whatever it needs, that it will automatically do. Okay, so the idea is this, you see that this thing, whatever we printed, that thing is running fine. But apart from that, it is also does some code optimizations, right? This is like plain and simple, it is working, right? But bundling into a single file. But right now you can see that we are running in development mode, right? If we do something like production mode, and then try to build, then try to see the file, you can see that it is pretty small, it is pretty small. So what it, so you can see that it has optimized the code too much. So it saw that, yeah, you are trying to create a variable a, print a variable a, and that variable you are importing from foo.js, and webpack can see that this module is not used anywhere else, so why not just take this 10 and hard code this directly here, and that is what it did. You see that in the final output it is directly here, and you can play around with it. If let's say you have another file and there also you are using foo, then it will not directly embed, so it will try to make the code as simple as possible. If it cannot make it much simpler, then it will keep it slightly nuanced, but it will try to optimize code as much as possible. Next, you might be thinking that why this use strict thing is there. That is because automatically when, so for example, let's say you are doing something like this, right, and let's try to build it, then you can see that this thing is like normal, right? And but if you are doing something like let's say anything like, let's say export const x is equal to 5, somehow if it sees that you are trying to use es module syntax, which means that you are trying to make this this is like es module, right? If this is es module, then webpack will see that, yeah, then all the other things has to happen, right? What is the first thing has to happen? We know that in es module the code has to be in strict mode, so you can see that automatically use strict is added by webpack. I'm just giving you an example that if you use webpack, then webpack internally takes care of all those things. And what is this not question mark, you can understand. So, so these things automatically ultimately when it will execute, then whatever the behavior is here, so it is like printing a, as we saw earlier, that whatever is the behavior, that behavior will be simulated by webpack, provided and at the same time it will also support all the other module systems and syntaxes and parsing logic, everything what is required for it to make your code performant and compliant across a broad range of browsers, right? So that is the purpose of Webpack. So code optimizations it does, that is fine. Strict mode also automatically it created, we saw, and that it automatically can see that whether you are using ESM or not, and based on that it can enable strict mode automatically. And apart from that, we don't need to add some packages also here, because automatically and that was not needed for browser only also. It's just that while npm run build also, even though the build is happening of a file which is of ES module, but since it is not executed natively in ES modules, it is just a bundling part of that, which JavaScript, which sorry, Webpack takes care of. That's why this type module is also not needed. Okay, and now comes the most interesting part. The interesting part is that if Webpack can transform each of the piece of code, like all the code to, let's say, it converts, let's say, ES modules to common JS, or let's say it converts um, so we saw that here we are writing ES5, right? ES5, which means that if we write here something like let's say this thing, and then we simply say that function foo, and let's say we are using an arrow function, so const foo is equal to anything, so let's say log a plus 1, something like this. Now you can clearly see that this is and then we call foo, right? We can clearly see that when this piece of code will run, right, then it will take the a value from here 10, it will add plus 1 11, and it will call that function. But if we try to build this, right, then we will see that this is like optimized code, right? But even if we don't optimize it, let's say we are simply using let's say development environment, right, then also we'll see that the code uh, will be transformed into this. You can see that this is like this is like ES5 code, right? It is like const is converted to var, arrow function is converted to normal function, and it will behave still like the same thing. So whatever is the behavior here, if you do npm start, right, then obviously all those transformations are done appropriately, so that the behavior is still like 11 should be printed right here. So you can see that I am using this index.js, which is required from here, and the web page is this running, and you can clearly see here also that if you see here, then this file is actually the file created by Webpack, though it is a development version, but still this is a file created by Webpack, and it works as expected, right? So 11 is expected and 11 is printing, so the workings will be perfect. But the idea is that you can clearly see that this bundling might transform the code. But the idea is that if we are transforming the code into ES5, then and then browsers are working hard to implement the latest and greatest ES6 features right inside the browser, then what is the advantage of doing all those things? If browsers are doing that thing and we are not able to use those features in the browsers, just because of the fear that not all people are having this modern browsers, and that's why we need to convert our code ES6 to ES5 so that all the browsers are supported. And that is the problem, because of which we are not able to take the full advantage of modern browsers. So what is the solution? The solution is, what if there is a way in which, if we have modern browsers which supports this, let's say ES6 modern syntax, module syntax or something, then we have a different version of file which can support ES6 also, And for the other versions, let's say for older browsers, automatically that newer version of file will be ignored, and the older bundle will be considered, which means that essentially we will be creating two bundles, one new bundle. So right now what is happening, right now we are building npm run build, and just one bundle is being created, right, this thing. Now I'm saying that let's create two bundles, one for modern browsers and one for old browsers. And can there be a way in which I can tell modern browsers to use the modern one and older browsers to use the older one? Can it be done? Turns out it can be done, and that is why this syntax is used. So for backward compatibility, it can be ensured by using the attribute no module on the script tag. So on a script tag there is a attribute called no module. Okay, and type module we already know, right? So how this works? What happens that earlier earlier we used to have only one file, right? What one file we used to have? We used to have only one file, something like this, uh, script src index.js, something like this, like just one file. Now I am saying that let's have two files. Okay, one is like the, let's say let's say ES5 version, and let's say one have ES6 version. Let's say it supports ESM module. So let's name that index.esm.js. Just any name you can give, but just I'm giving this name, that this is a file which supports ESM, or it supports, let's say, newer syntax. For that matter, it does not matter whether it has all the features of ESM or not. The point is that it is like ES. You can name it ES6 also, that is fine. But the point is that this is like newer file, this is the older file. Now you see that I can what I can do is that I can write something like this: type is equal to module, type is equal to module. And when I write type is equal to module, then automatically this syntax will be used, this file will be used, right? So you can see that this file, so let's say this is ESM, and I write this type module, then automatically this file will be treated as module syntax. That is fine. But I don't want and modern browsers will run this because as module, but I don't want the second file to be run. For that, the syntax is no module, the attribute is no module. If I write no module, then, and no need to write any value, just write no module, then the modern browsers will automatically understand that since I support module and it is written no module, then I will not run this file. I will just run this file, but I will not execute this file. This is a way that modern browsers support this, right? So wherever type is equal to module is supported, at the same browser no module is also supported. So whatever you want to run, write module type module, that is the newer version module system file, and wherever and whatever is the fallback thing for the older browsers, there you write no module, that is not supported, and that's why it will not be run in the modern browser. Means not supported means it is supported, but it need not be run in the modern browser. That's why no module is there. This is the easier part, because now I am clearly saying that what should be run in modern browser, and all these syntaxes are created going forward, so modern browsers can understand this syntax. But how do you convince yourself that for the older browsers the opposite thing will happen? Which means that for the older browsers, the first one should not run and the second one should run. How do you ensure that? That is also ensured automatically, because you see what happens. The specification of script tag says that type should be like what, if nothing is there, script tag nothing is there, then by default it is like what, application text JavaScript or something like that, which means that it is JavaScript meme type or something, right? If any invalid type is there and type module is invalid, why? because let's say 5 years ago or 6 years ago, when 10 years ago, when ES6 was not there, then type module was not invented. If type module was not invented, then that point of time, for earlier 10-year-old browser or 8-year-old browser, type module will be considered invalid, and that's why those browsers will not run this first piece of code. That is the first thing. Second thing, they will come to this line and they will see an attribute no module. Again, this no module is a new attribute. It is a new attribute added to the recent version, right? This is invented newly. This attribute does not exist 8 years ago, which means that the older browsers will not understand this. And if any attribute is not understood, then it is simply ignored, which means that the second will be as good as simply script src fallback, and that is exactly what we want. That is exactly what, so in that fashion, the second one will run with no module ignored like a normal script, and the second one will not be ignored. Second one will be executed like a normal script, because no module will be simply ignored. The the first script will be ignored because type is something which is invalid, and that's why all the older browsers will ignore the first one. And that is how we achieve the functionality that we will have two such bundles, and then the modern browsers will use this bundle, run this bundle, not run this bundle, and older browsers will run the second bundle, not the first bundle. Okay, so that should be fine. Now let's try to run this. So actually there are ways in which webpack could be used to keep the ES modules. I will not go into those advanced configurations because that is a whole lot of things, but right now I'll just give you an example. So let's say, let's create, so index.js is already there, right? So let's create index.esm, no, index.esm, right? So new file, index.esm.js, right? And let's say that let's say that this thing is as it is, or let's take a simple thing. So let's say simply this function is there, right? And this function is called, okay, okay, okay. And let's say here you are using some export const or some module system you are using, but right now we are just trying to demonstrate something, right? So let's take a simple example where you are using a normal function, right? So let's say module features you are not using, but that should be fine, but that is part of this. And here you can understand that since this is ES5 code, older code, then let's convert it to like normal function. So you can understand that it's like function, you understand, right? So I'm just having a plain idea that actually so right now if you run node index node public index.esm.js, then you can see that this a is not defined, right? Yeah, so let's create let's say a const a is equal to 10 or something. I'm just giving a simple example. And if you are using a older version, then you will rather have something like var, because latent const were declared later in ES6, right? So I'm just giving an example that let's say all these will be done automatically by webpack, but I'm just saying that let's say you had this file, you developed this file, and this was like had everything like ES module syntax, everything. It has ES6 plus code something, and let's say this thing is converted by webpack to something like this, which is like normal ES5 code or something, right? Now you can see that yeah, this thing will also run and this thing will also run. What is the difference? The difference is that, yeah, right now the modern Node.js and the modern browsers both will run both, but we are interested in that something like this, that now I'm saying that what if this index.esm, this thing is run using a module, because I know that this is a modern code, and it will have support for ES6. It will have it can have support for modules and everything. But this second piece of code, which is simply index.js, this is only supported by older browsers. Let's see what happens if I do something like npm start, right, and I go to network, I clear everything, I go to console, I clear everything, and I refresh. See, 11 is printed, but 11 is printed from which, this file or this file? Let's check that. Go to the network tab and you can see that index.esm.js is called. You can see that this thing is called. Index.js is not called, and that is because this is a new browser. This is a new browser, right? Since this browser is newer one, that's why the same piece of code ran, but it did not at all execute this piece of code, right? Had we tested the same piece of code on an older browser, then we would not have executed this first line, rather we would have executed only the second line if ES6 was not supported. So as we discussed earlier, that we could do that sort of testing using an online tool called browser stack. First of all, we have to see that what is the version which we are looking for, that where it will not work, which means that what is the definition of old, where it will not work. That for that you can Google something like can I use ESM or can I use ECMAScript modules. There you will use you'll get this caniuse.com, where you can get the versions where you can clearly see that in which browser supported JavaScript modules via script tag in what version. So you can clearly see that yeah, Chrome till 60 did not have support. In 61 Chrome, in Chrome 61 they did have support for this thing, which means that this syntax type module was introduced in Chrome 61. So let's try to, and we saw that in our case right now that index.esm.js was done, right? So which means that from 61 onwards, whatever Chrome version is there, from 61 onwards, everywhere we will have they will be able to understand this syntax, no module syntax, and this syntax, and that's why this thing will be executed. Now let's try to run on a version which is less than 61. So let's say 60. Right, now you can go to browser stack and obviously I'm just showing you don't need to do this on your own because this is a paid thing, but anyways you can try this on your own if you have an account. If you don't have an account, then I'll show you that. Let's go to 60. Yeah, so let's go to 60, and if we are running the same piece of code, which means that this localhost 3000, right, the same thing, if we run on Chrome 60. So let's see. So console, we can see that nothing is there. What do we expect? We expect 11 to be printed, right? Network, nothing is there. We go here, we run this thing, and now you can see that index.js is called rather than index.esm.js, and still the answer is exactly same. So yeah, so that is how it works, that for older browsers automatically this will run, this will not be downloaded, and for the newer browsers this will be downloaded. First one will be downloaded and run, and second one will not be downloaded at all and not executed at all. Okay, so now I believe that you have got a fair idea that how these sort of support for older browsers work. So and how ES modules can be integrated in browsers for that matter which you support, and what is the advantage? The advantage is that yeah, now if let's say this we wrote manually, right, but let's say this piece of code is like let's say 500 lines of code, and using webpack, using all the polyfilling and transformation, you understand. So if some browser understands arrow syntax, then why do we want to convert into this syntax? The size of the bundle might be increasing, right? So the size of the JavaScript bundle will increase, which means that for the newer browsers, if we use the newer file, then that page will load faster because this file will be smaller, and that's why it will be downloaded quickly. right? But for older browsers we have no option, that's why we have to download a bigger bundle. So in this way the best of both worlds come to our way. Okay, so that is fine. That is fine. In this way we have understood a bit of ES modules. There's a slight more things left, like dynamic imports or something, which we'll cover somewhat later, but for now this should be enough. Okay, so see you in the next one.